All right, guys, so what we're looking at here is the particle motion problem, a particle motion problem from 2017. This is number 5. Now, if you have a calculator, this problem is actually much, much easier. But I'm going to do this. This is on the non-calculator portion of the exam. And I didn't tell you that when this was assigned to you because I want you to understand better what's going on rather than how to do the problem. But I am going to walk through this problem as if I did not have a calculator to correctly answer what is going on. So we look at this problem. We've got two particles moving along the x-axis. For time between 0 and 8, the particle's position p, so I've got my first particle p, and its position equation right here. Now again, that's important because it also gives us the velocity of particle q. So one of them is a position equation, the other is a velocity equation, and it tells us particle q has a specific position at a specific time. So letter A wants to know when is particle P moving to the left. Now again, if you had a calculator, all you'd have to do is we need to take the derivative of this, and the derivative of the ln of t squared minus 2t plus 10 is 1 over t squared minus 2t plus 10. And then we multiply that by 2t minus 2. Now, in order to determine where this thing is moving to the left, what we have to do is set that equal to 0 and find out where the critical point would be, and then find out whether it's positive or negative on that given interval. So in order to do that here, we take the top and we set it equal to 0, and I get t is equal to 1. That's one place. And then technically, and again, this problem is much more difficult than you probably thought without a calculator, but we also have to set the bottom equal to 0, and it doesn't factor out well, so I don't worry about it, but we should do that. So t equals 1 is my one critical point. Once I know that, I put that on a number line, and I put in numbers that are bigger and smaller than 1 into my equation here. So let's say I put 0 in here. I put 0 in. 0 is going to make the top of my derivative be a negative number, and the bottom be a positive number. A negative divided by a positive is a negative, so that means it's moving to the left from 0 to 1. If I plug in a number bigger than 1 like 7, that gives me a positive number on the top, and that also gives me a positive number on the bottom. So a positive and a positive, that's positive, that means it's moving to the right. So particle P is moving to the left from 0 to 1. So that is your answer for letter A. Letter B wants to know, find all the times in which the two particles travel in the same direction. Well, we already know how particle P travels from 0 to 1. So if I made myself a number line for P, we just did it. From 0 to 1, I am moving to the left, and then from 1 to 8, I am moving to the right. We already discovered that from letter A. For the velocity of particle Q, what we have to do is, we're already given the velocity, so I need to set that equal to 0 and find out when it's moving in what direction. So I'm going to have t minus 5, t minus 3. So I've got 5 and 3 are my critical points. So I put those on a number line. I've got 3 here, I got 5 here, and I plug numbers smaller than bigger to find out what's happening. So if I plug 0 in, I get 2 negatives, which gives me a positive, so it is moving to the right at that time. When I plug in 4, 4 gives me a negative, which means it's moving to the left from 3 to 5. And if I choose a number bigger than 4, like 6, then I am moving to the right again. So now what I have to do is compare these two different things to find out on what intervals is it moving in the same direction. Well, if particle P is moving from 0 to 1 to the left, and 0 to 3 for particle Q is moving to the right. So from 1 to 3, they're moving in the same direction. And also from 5 to 6. Those are the only times they're moving in the same direction. And in both of those cases, they're moving to the right. It doesn't ask for any justification, so we just had to have those two time intervals in order to understand that. Now, again, I understand this problem is much easier with a calculator because you can just graph the derivatives and see when they're both above or below the x-axis. But in this problem, without a calculator, that's how you would have had to go about doing that. Letter C says, find the acceleration of particle Q at time equals 2. So to get to acceleration, I just take the derivative of the velocity. That gives me 2t minus 8, and then I plug in 2. So 2 times 2 minus 8 is negative 4. There's your acceleration. If I want to know if the speed is increasing, decreasing, or neither at time equals 2, I also need to know what the velocity is at that time. So I'd get 2 squared minus 8 times 2 plus 15. That is 4 minus 16 plus 15 gives me, that is positive 3. So I would say that the speed is decreasing. The reason for that is my velocity at that time is positive and my acceleration is a negative number. Lastly, I need to find the position of particle Q the first time it changes direction. Well, remember, in order to change direction, we have to have our velocity equal 0 and change sign. And that's exactly what happens at time equals 3. So I know the particle changes position that's the first time it changes direction. Now I need to find the position at that time. So what we do is we take our initial position, that's my 5, plus the integral from 0 to 3 of t squared minus 8t plus 15 dt, and then we have to solve that. Now again, with a calculator, this problem is fairly easy. Without a calculator, I have to take the antiderivative, so I get t to the third divided by 3 minus 4t squared plus 15t, and evaluate that from 0 to 3. So I plug 3 in. 3 to the third is 27 divided by 3 is 9. 3 squared is 9 times 4 is 36. 5 times 3 is 45. So when I add all those together, I get 18. When I plug 0 in, to all those I just get 0. So 18 minus 0 is 18. I still have the 5 out front, so 5 plus 18 is equal to 23. Hopefully all of that made sense, where all of those came from. I didn't talk about the point breakdown as much on these problems, just because hopefully I can get you to understand where it's coming from. Again, without a calculator, this one takes a little bit longer. With a calculator, hopefully you were able to come to most of these answers at least a little bit quicker than the way we talked about it. If you have any questions, let me know.